brought to you by New York City Atheists Incorporated. I'm your host, Dennis Horvitz, the David Letterman of the Hopelessly Damned. Back again for this segment is our guest from last time, John S. Wilkins, who is the author of this book, Species, A History of the Idea. And John has a PhD from Melbourne in Australia. He's doing postdoctoral research. He is a postdoctoral research fellow at the University of Sydney. He has a diploma in computing, and as I said last week, my favorite of all of them is that he has 2/3 of a theology degree. Can you briefly tell me what happened to that other third?
Yes. For personal reasons, I suddenly called into question my religion at one point and decided that I couldn't reconstruct my belief, and then realised that this sort of made doing the rest of the theology degree odious. So, lacking an audience to bore with my sermons, I decided to become a philosopher instead.
You see, I'm still not sure why you let lack of belief in God interfere with your getting a theology degree.
Well,
I mean, so many other people don't let.
While I was studying in an Anglican college, nevertheless, it was a believing Anglican college, and I didn't think I could go on honestly and do the rest of the degree. Besides, I to this day don't know what use it would have been to me. The most I could have become was a preacher in the Anglican Church. So.
Right. Would that have made you a vicar? Would they call them vicars?
If I'd chosen to go the full ordination route, yes. But I've always studied stuff for interest's sake and for no earthly use. So probably I wouldn't have.
Well, at least we have that in common. My mind is a virtual encyclopedia of information that will do me absolutely no good.
Yeah. At one point I was bragging that I'd never studied anything of any practical use, but then I did the computing degree.
Right, yeah. Well, in any case, just before the show we were actually discussing, last week's show we were talking about Darwin and evolution, and we mentioned natural selection, and before the show we were discussing a phenomenon that is going on in Australia, that being the cane toad. So, why don't you just give a little background of what happened with the cane toad?
Well, as your viewers may know, cane toads were introduced to Hawaii in order to kill beetles that were causing problems with sugarcane, which of course they didn't do, but at the time I think it was the British who were doing most of the sharing of noxious pests. So somebody decided that it had worked so badly in Hawaii they'd introduce them to Australia as well, whereupon, as you pointed out, they continued to eat everything except the pest that they were brought,
which we call the cane beetle.
The cane beetle.
So they ate everything but the cane beetle.
Yeah, basically, including most other frogs, which meant that there was a major ecological gap. They've spread from where they were introduced in northern Queensland to one of the last remaining wildernesses in Australia that is a wetlands, the Kakadu National Park.
Now this would be, I guess this would be an example of natural selection, apparently, and I read this within the last year or so, that there are certain, I wouldn't call, I guess it's too soon to call them a subspecies or a species.
Yeah, but there are varieties.
A variety of cane toad that has actually grown longer hind legs.
Yeah, apparently the ones at the border do better at reproducing if they get into an area first. So they're moving faster.
Right.
But what's interesting is that once the population is no longer at the border, at the boundary of the expansion of these cane toads, it reverts back to the original type. So it's a kind of transitory benefit that you get only, it's sort of like moving west, you know. Those who can go the furthest are going to get the territory first.
Right.
But once you're there, you want to become a respectable citizen. And the other thing that's interesting is that a water snake that eats frogs, which we were worried about becoming extinct because of the cane toads, has evolved a smaller gape so that it doesn't eat them when they're old enough to be poisonous. And this looks like it's coming back. So evolution everywhere. You can't stop it.
Right, but we have to make, I guess you have to make a difference between evolution and specifically natural selection. Is that correct?
Yeah. Well, yes. Natural selection and evolution are distinct. in that natural selection can cause change, but it can also cause stasis. Stabilizing selection maintains populations at local optima. Right. And this means that basically you won't see any change. When people talk about natural selection and evolution as being the same thing, I immediately object because they're different things.
In other words, if you were to take a long-legged cane toad, they could still interbreed with a short-legged cane toad.
Yeah, well, I mean, that gets back to the notion of species. Interbreeding is regarded by many biologists as a necessary condition for something being the same species. I don't think so. And the reason I don't think so is because the reason I don't think so is because
That's probably my agent.
The reason I don't think so is because there's extensive hybridism in pretty well every group of organisms that we look at.
We're having to cut because the camera.
Oh, okay.
The camera moves, so.
Yeah.
Okay.
Okay, so you want to take it back?
No. You just keep going and I will edit it out afterwards.
Okay. Interbreeding has been regarded as a test of species, but we've found recently that wherever you look, there's hybridism between different species. I've just been at a conference in Germany where they were discussing hybridism amongst primates.
Right.
And they were quite shocked at the extent of empirical evidence there is for interbreeding and gene flow between different species of baboons, different species of monkeys, possibly even between proto-humans and the proto-chimps.
Yeah, I hear, and now in Darwin, I guess Darwin, in your book, you explore the effect that Darwin asked the question, what would be the changes necessary to prevent interbreeding?
Darwin was a very, very sharp guy. He actually said interbreeding is not the test.
Right.
And the reason he said interbreeding is not the test is because at that time everybody knew hybridism went on. In fact, we've known that since Aristotle.
It's very interesting.
It's only in the 20th century that the myth grew that species don't interbreed, and people stopped looking.
That's very interesting. And that's funny thing is because we in some ways we have evidence of this all around us.
Yes.
Yes. I don't know if this would be an example, but a horse and a donkey.
Sure. Well,
mules.
Yes. So typically people thought mules aren't fertile, but there is a form of mule, a hinny, that is interfertile. Right. So that means that ass genes can get into the horse population, or the other way around. Right. I can't remember. Lions and tigers can interbreed.
Yes, ligers.
Most species of dog can interbreed, including coyotes and wolves and wild dogs.
Very interesting.
African dogs. The idea that gene flow is restricted between species was pretty much an invention of the mid-20th century.
That's very interesting.
And people stopped looking. And just recently they've started looking again. Well, just recently, I mean, the last 20 years or so. Botanists always knew this happened. Mm-hmm. Coral specialists knew this happened. I talked to a coral specialist and said, what makes a coral species? And he said the prevailing currents when they broadcast their gametes into the water. Right. I said, what do you mean? He said, well, as Australia moves further north, because we're talking about the Great Barrier Reef,
by an inch
the currents change, and that's going to change who fertilises whom.
Right. So by the time you get back home, it's going to be,
I'm not going that long.
Fractions of an inch.
I don't think it's going to make that much difference.
I just don't want you to land in the wrong spot. That's what I'm just concerned.
I'll trust the airline.
Okay.
I'm flying British Airways. So the thing is that the idea that species are somehow distinct gene pools was an invention of people who had some sort of vested interest in the idea that gene pools are what make species. And the villain of the piece, the villain of my book, although I'm told he was a very nice man, is Ernst Mayr.
I was going to ask, right? So he regarded species as a gene pool.
Yeah, as a protected gene pool.
A protected gene pool.
And unfortunately, he made mild concessions to there being occasional hybridism, but it was rare.
Right.
It now turns out it's not rare. It's ubiquitous. You find it all over the place, and that's the nature of the world. So biologists are starting to have to come to terms with this. And it means that no one definition of what a species is really works.
Yeah, I mean, that was one of the questions I was going to ask you the last time. How much farther along are we into any kind of
Well, I think we're a
definition?
long way along now, actually, because A, we've got a lot more data, we're empirically better informed. But also, people are I mean, scientists are great practical thinkers. They will employ any tool that's in the shed, doesn't matter what. The principle plays some role, but basically, if you can, give me a technique, I'll use it. So the current crop of techniques involve what's called genetic coalescence, where you try to look at the history of genes to get an idea of whether or not this is the same species and what have you. And that works for some groups and doesn't work for others.
See, that whole interbreeding thing is going to make creationists very nervous, I think. They're going to want to go get rid of cute gorillas.
Do you want to know a funny story? One of the people who repeated Aristotle's story that new species were formed by hybridism was George Abbott, the Archbishop of Canterbury, who was one of the translators of the King James Bible.
Very interesting.
There's a book called God's Secretaries, which recounts this. And what the author of that book didn't realise was everybody repeated this story all the way back to Aristotle. Pliny put it in his Natural History, and that was the standard encyclopedia for educated people for 2,000 years.
Now, is that Pliny the Elder or Pliny the Younger?
I don't know whichever one wrote the Natural History. I think the Elder.
Yeah, I think it was Pliny.
It was the guy who died in the eruption of Vesuvius.
Yeah.
Yeah, I think that was the Elder.
But I think it may have been Pliny the Younger that actually wrote a whole something about he had a list of just different species and opinions about general things, and actually he was fairly rational for his time in terms of...
Yes, but I mean, there's a kind of myth that people were stupid before Darwin, and that on November 15th, 1859, they became really smart. In fact, when I look at the way people actually observed living kinds, they were always fairly rational. I mean, the people that you'd want to call natural historians.
Right. Well, and they were dealing with the information that they had.
They were dealing with the information they had. Yes, they made mistakes. But look, one of my favourite people in history is Frederick II, who was a Holy Roman Emperor in the 14th century. I like him partly because he got excommunicated twice. And he was a man.
That takes talent.
That takes real talent,
yes.
Yeah. The second time for not killing enough Muslims. Frederick was a mad falconer. I mean, really mad falconer. It took nearly as much of his time as it did to be Holy Roman Emperor.
And probably a better pursuit as well.
Well, yes, he had something like 1,000 birds and several hundred falconers, and he wrote the book on falconry. And in that book, he says things like, some people say that these are two different falcons because they have different plumages, but in fact they interbreed, so therefore they're the same species. He uses the word, it's the Latin word for kind. And he is very good at this. He lets Albert the Great, Albertus Magnus, Aquinas' teacher, have access to all of his falconers. And Albertus Magnus writes his History of Beasts, and the volume on birds is very, very accurate. So people weren't stupid. They were good observers when they gave it the time to look at these things.
But I think, and again, I don't know whether it was Pliny the Elder or Pliny the Younger, but he does list things such as there were people in Africa that had no heads.
Yeah, well, I mean, there was always that. But
no, it wasn't because they were stupid. Because
how would you know whether it's right or wrong?
They would have no reason. They would have no reason not to.
Yeah, you hear a story. You believe it. But interestingly, in Fred's book, he says we can't believe Aristotle. Now, this is within 50 years of Aristotle being translated. We can't believe Aristotle because, on the one hand, he's credulous. He believes hearsay.
Yes.
And hearsay isn't a good path to evidence.
Right.
To truth. And the other is because Aristotle knew nothing about falconry. So... You gotta love this guy.
Well, that makes him suspect immediately.
Yeah, absolutely. Well, it did to Fred. Yeah.
I kind of want to jump around here.
Good.
And you told me this before, but if you would just kind of, there's an expression that I actually was taught in school, the concept ontogeny recapitulates phylogeny.
Yep.
And this is actually obsolete. It's not operational.
Yeah,
If you could just give a little background as
Okay.
to why
Well,
that's true.
So
why it's obsolete.
All right. Well, early in the 19th century, Carl Ernst von Baer had discovered that the changes that happen in the development of a fetus that were changes that were characteristic of broad groups, like all mammals or all dogs or whatever, happened earlier in the development of the fetus, and changes that were more specific, African wild dogs, happened later.
Right.
Okay. Darwin knew of this. It was one of his evidences for evolution. But Ernst Haeckel, who was a German naturalist, and a very good one, I might add, because this diagram is one of his. He was a beautiful artist. This comes from a volume he published in the late 19th century called Art Forms in Nature, and if you can get a copy, it's well worth getting. It's beautiful.
Haeckel, right.
So Haeckel thought that von Baer's principles meant that what happened was the fetus underwent the changes of the adult ancestor.
Right.
So he expected that the fetus would resemble the adult form of some ancestral species that was ancestral to the group. Ontogeny, that is, the development of the organism, recapitulates, that is, goes through again, phylogeny, that is, the evolutionary history of the organisms.
Right. Okay. I remember being taught that.
Now, that was false then. It was known to be false then. Haeckel was an enthusiast, and he tended to go a long way on very little evidence with some of his greatest ideas.
But he wasn't the villain that he was made out to be.
Oh no, people accuse him of instigating Nazism, they accuse him of
scientific
scientific fraud
Yeah.
and all that sort of stuff. In fact, pretty much everything that people accuse Haeckel of was standard practice of the day. For example, trimming away parts of diagrams so that you could see that's standard practice even now.
Right.
There was a woodcut that was used more than once in one of his books, showing the development of similar features.
This is because I remember seeing that myself as a kid.
Creationists make a lot about this.
Right.
In particular, that execrable book by Jonathan Wells, Icons of Evolution, has made it one of the talking points for creationism. But in fact, the academic trial that was held, exonerated Haeckel and said, okay, it's a little iffy, but he hasn't done anything wrong.
Right.
And what I find is a lot of people, for example, Herbert Spencer, so-called author of Social Darwinism, was a standard liberal Democrat. Right? He was like John Stuart Mill, who was a friend of his. Most of these people have been demonized because of the way they've been used after their death or after.
I was going to say that somebody with an agenda has has kind of quote mined, if you will.
Sure, exactly. And good God, Darwin was used by both the Marxists on the one hand and the fascists on the other. I mean, what is he? Is he a leftist or rightist?
Right.
Has he caused, which particular moral error is Darwin responsible for?
Right. And
the fact is, Darwin was a scientist.
Yes.
And he was very careful not to draw social conclusions.
And they accused him of endorsing, they accused Darwin of endorsing racism, which in fact...
Yeah, and eugenics and all sorts of things. Look, I mean, there's precious little historical basis for it. But the fact is, even if it were all true,
right,
it doesn't change the fact that the overall story that he told scientifically remains our best account.
Right.
He could have eaten live puppies for breakfast. It
That's
wouldn't
right.
have made any difference.
That's right. Empirical results are...
puppy.
I like them semi-conscious myself. Talk about two sick puppies. Monkey brains. Right. Let me just, if I can just kind of jump to a kind of another thing. You mentioned before about a concept which I had just heard about, actually from you for the first time, called teleosemantics.
Okay. This is a movement in philosophy of biology and philosophy of language to try and give an account of how it is that words and ideas are about things in the world without them having some sort of divine influence or various other philosophical nonsense.
Implying purposefulness, yeah.
Yeah, that we don't particularly want. And so teleosemantics is the idea that you can give an account of why something has a particular function or a particular meaning in terms of its selective history. Mm-hmm. So, for instance, the eye is for looking because the eye was selected for that purpose.
Right.
The left nostril isn't for anything particularly because it wasn't selected for anything particularly. You know, that's the idea.
Well, the teleology is basically a philosophical approach that there's a purpose in nature.
Yeah, well, teleology is the attempt to find purpose,
right,
and find design. So one of the, I think probably the most general impact that Darwin had in general society was in fact the death of teleology,
right,
because he gave a reason for why things look like they're designed, why things look like they have functions and purposes, without there being a purposer or a designer. And everybody understood what that meant very early on. Now, while Darwin was not the first person to give something like that, I mean, people like Adam Smith and David Hume had similar ideas at the end of the 18th century. Nevertheless, Darwin brought it home in a solid way. And one of the things Richard Dawkins has said that I do agree with is that Darwin made it possible at that point to be an intellectually fulfilled atheist, because now you had a reason for why things have purposes and designs without there being a purposer or a designer.
Right.
And I think that was, I mean, you read all the literature of the late 19th century, that was the thing everybody focused on, that Darwin has killed teleology.
Right. Well, you know, and as I mentioned last night, that it seems to me that we're in some ways, though, the public discourse still involves a lot of teleosemantics, and I use it as an example when we watch the Discovery Channel, for instance, on cable.
Somebody will say evolution has chosen this way or solved that problem.
And I mean, they do have to sell soap and car wash and that kind of stuff, but I find that there have been some really brilliant shows in the last 5 or 6 years about dinosaurs, and I'm not disputing necessarily the information provided, and of course the graphics are tremendous, but there is a tendency for the commentary to portray what, first of all, is not solid information about their behavior. We may or may
not know what.
Yeah, right. Yeah. But for instance, a female dinosaur will lay eggs, and there's the tendency that she understands what all this means in some larger sense. Yeah. That she's providing, and basically she's doing it completely out of instinct.
Yeah.
And
for any of this stuff, if you can read it as this happens in order to do that. Yeah. That's what you would call intentional language.
Yeah.
And I mean, look. Human beings evolved to deal with intentional objects, that is, other human beings. So the most complicated thing we deal with is each other.
That's right.
Surviving doesn't take all that long.
Right.
One of the main hypotheses for why we have big brains is so that we can understand other people. But that means that we see things in intentional terms. We see the world as if the world was run by agents like us.
Right.
And
well, human beings, we think that reality is about us.
Yeah, we project ourselves onto the world.
Probably an evolutionary...
And this is referred to as anthropomorphism,
yes.
Projection, a whole lot of other things.
And the anthropic principle and all of that.
The problem is, if you're trying to sell an idea in science, particularly a biological idea where you think, everybody thinks they understand biology because they're biological, and they've got cats, you know, they've seen trees, all this sort of stuff. Everyone thinks they understand a lot about biology. So when you're talking about something like evolution, which is really outside the experience of everybody, it's really, really hard to get across the logic of what you're talking about without using intentional language.
Right, because it's counterintuitive to just just say that it is.
And if you push people who talk about these things, they will say, oh, well, I'm using this as a roundabout way of expressing it. You can get rid of all that.
Oh, yeah, and you're not a big fan of metaphor.
I'm not a big fan of metaphor.
I know that.
I think actually it's better to teach people to think without the metaphor, because even those people, and I hesitate to say even Richard Dawkins.
You think he has that tendency?
I think he has that tendency to let the intentional language guide the reasoning about the way things are. And I think it's a mistake.
But it's so ingrained into our culture, to human culture.
Yeah, it is.
It's hard for me even to. I have to catch myself, and like I started to say, when I see these shows on television that are basically very educational, provide lots of information in a very entertaining and nice way to learn. But I always wince when as soon as they, I have to tell you,
if you were teaching a young kid about what happens when you add an alkali to an acid, what you would not say is the alkali and the acid want to form carbon dioxide. Right. But that's the way we teach biology, and I think that's a mistake.
I actually was watching a television show last night after we met, and it so happens it was dealing with Arctic ice in the Arctic, and about how icebergs form and what happens. And it was a great show because it talks about how these icebergs, aside from being a danger to shipping, but in their own way actually contribute to the ecology, the whole deal. But at some point they break up, they melt and break up, and it describes how when the sun actually hits the top of, and the temperature of the water and the sun both contribute to it, but what really actually causes an iceberg to melt is that as the ice melts on the top, it goes down through fissures in the iceberg itself, and it's this rotting from the inside that is actually has more of an impact on the death again, of an iceberg. And it was great. I'm not going to go into it, but it describes what happens is that eventually the iceberg becomes top heavy.
Yes.
And starts to roll.
Yes.